All right, ladies and gentlemen, so we are going to go through those bell ringers together. Just because I know those ones were more difficult, I put a couple pretty difficult ones on there just to see how we would do. So if we take a look at that first one, the first thing I do want us to pay attention to is, if you guys remember, I told you guys, if you see the polyatomic ion on both sides, that you could keep them together. And if we notice that this OH is over here, it is a polyatomic, but if we look on the right side, do you see that OH over there? Hopefully you guys say no, and that's because it is not based on what we are looking at right now. But if we wanted to see an OH there, what we would do is change this H2O. If we rewrite it as HOH, we can imagine that there's hydrogen is by itself and this OH is together. So if you see an OH on one side, this is an option if you wanted to keep your H's and your O's separately. All right. Do we want to keep the OH together, or do we want to do just H and O when we saw this one?
Keep together.
Keep it together. All right. So then we're going to make our different elements in polyatomics. So what are the elements or polyatomics we see on the left side, that reactant side? Anybody know one of them?
Lead.
Lead, perfect. So you have lead. What's another one?
Hydroxide.
Hydroxide, perfect. Two more.
Hydrogen.
Hydrogen
And chlorine.
and chlorine. Awesome. I know they don't look they're not in the exact same order on the right side, but I like to keep mine in the same spots just so I can just look straight across my column. So I just double check that I have a lead, I have a hydroxide, I have a chlorine, I have a hydrogen, and I have a chlorine. So now we have to identify how many of each we have. So on the reactant side, how many lead do we have?
One.
We have one, perfect. How many lead do we have on the right side, our product side?
Two.
On the product side, we have two?
They're one.
Just one, right? Yep. How many hydroxide do we have on the reactant side?
Two.
Two, perfect. All right, and then how many hydrogen are on the reactant side?
Three.
Three. All right, so this is where it gets a little tricky, is if we keep them separate, so this OH and this H, if we're separating them, the only hydrogen we need to worry about then is the one that's not part of the hydroxide. So we ignore these because these were already accounted for right here. So this is the only one we have to worry about. So just the one. So that's the tricky part when we keep those hydroxides separate. And then last but not least, chlorine.
One.
One, perfect. All right, and now our product side. How many hydroxides?
1,
1. How many hydrogens?
1,
1. Perfect, because we're remembering that we're keeping this section separate from this hydrogen right here. And then how many chlorines on our product side?
2,
2. Perfect. Do my leads, do they match up? They're the same number.
yes,
Perfect. Awesome. What about hydroxides?
no,
All right. So which side has less?
the right side,
The right side, my product side. So what can I multiply that product side to make it the same number as my reactants?
multiply by 2,
Multiply it by 2. Awesome. So now they're the same. And what do we do with this number 2? Where does it go?
you put it over the line,
I put it over the line right here. Perfect. We put it in front of our H2O or HOH. All right. And that 2 now goes into just the hydroxide?
also hydrogen,
Also the hydrogen. It gets distributed into both. So we multiply this by 2, and now we have 2. So now my hydrogens, do they match?
no,
No. So which side do I have to change? My reactants or products?
reactants,
My reactants. And what do I need to multiply my left side, my reactants by?
2,
By 2. Perfect. Use me 2. Where do I put this 2?
over the line,
Over the line in front of HCl. All right. And that 2, does that just go into hydrogen?
no,
No. Where else does it go?
chlorine,
Into chlorine. Awesome. Which means this gets multiplied by 2. Do my chlorines match?
yes,
Perfect. We're done. We balanced it. Woo! Any questions on that? All right. It does work the same way if you keep your H's and your O's separate and you didn't keep it as a hydroxide and hydrogen. It would work the exact same way. You get the exact same answer when you balance it. If you have questions on that one, let me know. The next one. So this one. For this one, do I want to change my H2O into a HOH? Do I want to change this to HOH?
no,
No. Why are you saying no? I like
because the reactant side doesn't have hydroxide, so there's no
exactly.
need.
Awesome. There's no hydroxide, so there's no need to keep it turn it into HOH. All right, so now let's write down our elements with their numbers. So on the reactant side, what elements do we have?
Carbon,
Carbon, awesome. What else?
hydrogen,
Sweet. And last but not least,
oxygen,
awesome. On the product side, we do have the same one, so we're gonna write down the same things over here. All right, on my reactant side, how many carbon do I have?
one.
We only have one?
Sorry, I was looking at the other one.
You're good.
8,
8, perfect. How many hydrogens on the reactant side? Oh, did I say products the first time? You were probably right. Ignore me. This one, talking about reactants this time. Yeah.
18,
18, awesome. And oxygens, how many?
2.
2, awesome. On the product side this time, how many carbons?
1.
1, awesome. How many hydrogens?
2.
2, and how many oxygens?
3.
3, awesome. And so when I write this one, I do try and keep myself a little more organized. Just because we see oxygen is in this compound, it's also in this compound, and they're both going to be added together, which is great. We did get 3. I do like to keep mine as 2 plus 1, just so I can keep them separate in the future, and telling me I have a total of 3, just so when I keep that in mind for later, because things might change, and so I know which oxygen I'm changing. So let's start with our carbons. Do they match?
No.
No. So which side do I need to change?
Product.
My products, and I'm going to multiply my products by how much?
8.
By 8. Perfect. Where does this 8 right here go?
Over the line.
Exactly, over the line in front of CO2. And that 8 goes into what? Just the carbon?
It also goes into the O2.
It also goes in the O2. Perfect. So this is why I keep my oxygens a little bit more separated in this case, because I'm just changing this one. I'm multiplying it by 8, which means how many oxygens do I have in CO2? Just from this section, how many oxygens do we have? 16, awesome. So I have 16 from here, which means in total on my product side, how many oxygens do I have?
17.
17, so this is 17 now. All right, and then my hydrogens, do they match?
No.
No, so how do I make my hydrogens match? Which side do I have to change?
You multiply the hydrogen on the product side by 9.
Awesome, and that gives us 18. And I put this 9 where?
In front of H2O.
Awesome. And that changes the hydrogen. Does it also change the oxygen?
Yes.
All right, so how many oxygens do I have just from the H2O?
9.
9, all right. So how many total oxygens do I have now?
26.
26. Careful, we're really close.
25.
25. And now my hydrogens and my carbons both match. All right, do my oxygens match?
No.
No, they don't. Can I make 2 go into 25 evenly?
No.
No, it doesn't go into 25 evenly, which is our issue. So now we have to go way back to the beginning. We have to change everything. So what's going to happen is we're going to put a 2 in front of here, which means now we multiply this by 2, we have 16. We multiply this by 2, we have 36. Now nothing matches. how can I get my carbons to match? If I already multiplied it by 8, my CO2 by 8, what else do I have to multiply it by to make my carbons now match?
2.
I have to multiply it by 2 more, which gives us 16. So now I have a 2 and an 8 that I multiplied it by, which means that this number gets multiplied by 2. So now it becomes 16. All right. And this 16 got multiplied by 2, which means now it's 32. We have to do the same thing with our hydrogens. So how much do I have to multiply this one by? My hydrogens. What number do I multiply my hydrogens by?
2.
By 2, awesome. Giving us 36, which means we multiply this by 2, which turns this into 18. It means this also turns into 18. So now how many oxygens do I have? Not 25, but
50.
50, which means how do I get my oxygens to match?
Multiply by 25.
Multiply this side by 25. How do we feel on that one? Good. All right, I'm gonna give you one little tip when we're thinking about this one. So this, what kind of reaction is this? Is this synthesis, decomposition, single replacement, double replacement, or combustion?
Combustion.
Combustion is perfect. It ends with CO2 and H2O, and it starts with some fuel source and oxygen. The biggest tip, though, is going to be something you have to think about this a little bit. But if you see a CH compound like this one, if our hydrogen, if this number, if when you divide it by 2 is odd, that means you're going to have to put a 2 in front here. So if that number divided by 2 comes out to be an odd number, that means it will not work out unless you put a 2 in front. So that's just a tip. If you want to think about that and remember that, that's fine. If you just want to go through the motions and do all of this work and keep going this way, it also works. Either way, it works. But remembering that if you divide that hydrogen value by 2 and it's an odd number, you have to put a 2 in front. It might just save you a little bit of time in the future. Are there any questions on anything we did today?